All right, welcome everybody to InfoRec webinar series. My name is Morteza, and I will be the moderator for today's webinar on the topic of industrial symbiosis, the national strategy for circular economy. The presenter would be my dear friend and colleague, Manuel Morales. Before starting the presentation, please allow me to provide a brief biography of Manuel. Manuel Morales is the director of Circular Economy Observatory within the Erasmus Monnet Chair. He also collaborates with InfoRec Research Group as a senior researcher. Manuel holds a PhD in economics from Kaunas University in France, and hopefully I'm pronouncing it correctly. I'm not butchering it. And he also holds a postdoctoral fellow in the chair of industrial bioeconomics at Neoma Business School. Manuel has published a wide variety of papers in highly regarded academic journals in the field of sustainability and industrial innovation and circular economy, such as the Journal of Clean Production or Resource Conservation and Recycling. Manuel has been a member of several internationally recognized societies and associations across Europe and in France. He has also been an active participator to several European and international projects on the concept of sustainability across, for example, Europe or Latin America. He has also been an active consultant in this area. So that's it. Without further ado, let us have the presentation. So Manuel, the floor is yours.
Well, thank you very much, Morteza, for such a kind and sharp introduction. And thank you everybody for joining this webinar. I hope that we will have a nice discussion, a nice place to discuss such the latest findings of my research. So let's start by defining the main topic. The title is Industrial Symbiosis, the National Strategy for Circular Economy, which means that among all the different strategies that circular economy is integrated by, we're going to focus on industrial symbiosis, which is one of several potential strategies. We will see further what are the others, what are the other principles that are also composing or integrating circular economy, but also other interesting thing that we came by in one of our research is the relevance of innovation, but not only the hard tech innovation, but also specifically the soft skills, the soft tech innovation into the implementation and the application of industrial symbiosis. So let's start then by showing a bit of the outline. We will see. So first of all, we will define what industrial symbiosis is for those who maybe have never been in contact with this concept. We will see how the complexity and the systemic approach that is embedded in the industrial symbiosis could be approached by a multi-level perspective. That is one of the activities that we make in our latest research, and also how system dynamics can handle and can deal with this complexity in the industrial symbiosis. We will go into a bit of a overall general outlook of industrial symbiosis from the regulations and from the legal standard in Europe, so how this how this industrial symbiosis is coming out from all the legal steps that have been positioned since the Circular Economy Action Plan, the Green Deal, and how everything is influencing and defining the boundaries of this industrial symbiosis and the incentives also by the public actors. In the number 3, we will give some examples about how comparative analysis in different countries has been a very interesting insight about how can we learn from different contexts, how the industrial symbiosis application is never the same. It's always depending on the actors, on the diversity of the context, on the situation. So this is very interesting in order to adapt the strategy to the context in which this is gonna take place. Number 4, we will present one of the research protocol that we developed in order to have a sharp idea about how can we integrate the drivers and the variables that are defining the circular economy, and how this could be taken as a policy recommendation into the development of industrial symbiosis in a specific context. And finally, we will end with a discussion about the relevance and the importance of innovation in the implementation of industrial symbiosis. So let's start by the point number 1, which is the industrial symbiosis definition. Here, just a very brief figure where we can see the Ellman Carter Foundation butterfly diagram representing the circular economy. As you might know, circular economy is not recycling, as many people think it was, but actually a lot of progress have been made in this dissemination and communication of the concept of circularity, because it's most of public actors and private actors already acknowledge that circular economy is different than just recycling. We can see in the left side the principles that mostly can define what circular economy means. The first one is the long life loop. So it means, how can we make products and services stay longer in the economy? And this will have an impact in the consumption of materials, energy, and everything that is needed for the production of these same products. So this implies an increase in the quality of the products. Number 2, this is the closing loops, where we can talk about the recycling of the materials, the biophysical characteristics of the materials, how to let them reintegrate or close the loops by taking away all the hazardous materials that are or could endanger the human life. So this is facilitating the recycling, facilitating the take back into the recycling loops. Number 3 is the extended loops, and this is very related with the industrial symbiosis strategy, which means how to identify what used to be waste, residues, and identify potential consumers that can take benefit out of this previously considered waste. How to valorize this material, this energy, or this knowledge, because also industrial symbiosis can be integrated by knowledge. And finally, the 4th principle is the intensifying loop. In the intensifying loop, we talk more into business models, how to improve the capacity of the companies, individual companies, into create value, but also into integrate this value or adopt this value. So we're talking about sharing of infrastructure, for example, the logistics, sharing of transport, of different kind of circular business models. Right. So just to trying to give the big picture here, we say, or we have identified from the literature review, that industrial symbiosis is an innovative circular strategy, and this is very well defined in the recent literature, because as I previously mentioned, when we talk about innovation, we have two different kinds of innovation. The first one is the high-tech innovation, which is represented by the infrastructure, by the technical means, by the algorithms, the software, the hardware, etc. But we have also the other kind of soft innovation, which means the governance, different modes, different ways of organization, different ways of the structure of governance, and this has also a very, very big impact into the improvement and the benefits that industrial symbiosis could have into a specific value chain or a specific industrial ecosystem, for example. We have in these three figures, three different cases that have been widely analyzed by the researchers. The case of Kalundborg in Denmark, which is one of the iconic examples of industrial symbiosis. We have also a very interesting example about Norrköping in Sweden, where the industrial symbiosis is based on the biomass coming from the forest bioproducts or biomass. And we also have some examples that have been widely analyzed from France in the Dunkirk industrial port. So how different industries that are not connected necessarily start to exchange, start to interconnect the different materials or different byproducts into transforming into a industrial ecosystem, which is able to valorize which previously was considered as a residue. Okay, so three main principles. One, we already identified or defined what is industrial symbiosis. We need to know that there are some criteria that needs to be fulfilled if we want to talk about industrial symbiosis. Industrial symbiosis needs to be integrated by different actors, so multi-stakeholder. One single firm cannot, even if it's a large corporation, cannot be considered as industrial symbiosis. It seeks to enhance circularity. It's one of the main principles that it is looking the industrial symbiosis. And of course, it's also looking for environmental efficiency and the economic allocation of products and byproducts. There are many researchers, authors that also consider resilience as a part of the required characteristics of industrial symbiosis, but not all of them. Okay, so here is what we are presenting as a novelty, as one of our methodologies that we are presenting as a tool that it's facilitating the complexity handle in this kind of decision-making processes. So we used a multi-level perspective approach in order to be able to integrate the diversity that is embedded in an industrial symbiosis. Industrial symbiosis has a diversity of products, diversity of byproducts, diversity of actors that are offering, but also that are demanding these biophysical products. And we also need to take into account the diversity of the interest, because it has different units. We are talking about environment into monetary units. So this complexity, it's not easily boarded or easily integrated by econometric models or by this kind of statistical analysis. But what we do is to propose a combined qualitative and quantitative method that is able to provide very interesting insights about the policy recommendations and the way in which industrial symbiosis can be implemented into different realities in different contexts. This is the transition multi-level perspective. In the multi-level perspective framework, we have three different levels, which is the macro, the meso, and the micro level. So different levels, but also different objectives. So in the macro scenario, in the macro level, we are mainly aiming to understand the biophysical materials. So all the biophysical characteristics without taking much interest into the specificity of the product. We are thinking only about the material. If we are producing plastics, we think about the plastic. If the product is made of aluminum, we think about the aluminum as a potential material to be reintegrated in the recycling process. But in the meso level, we are more interested into the supply chain integration. So this means what's the capacity of the collaboration, the coordination, the governance of the different actors that are taking part of this supply chain, how they can be vertically integrated or horizontally, how they can process digital platforms in order to improve their performance, have real-time analysis of their databases, etc. And finally, in the micro level, we are more interested into the specific innovation. That could be firms innovation, that could be different business models, kind of servitization, for example, changing how we are creating the value in our processes. And this is most related to a specific decision, business decisions of the firm or of the clusters in general. Here we have one example that one of the industrial symbiosis that I have previously analyzed as a diagnosis in a biorefinery in France, in Pomacle-Bassancourt. Different actors, for example, from the sugar beet producer onto the gas companies, the fuel producer companies are being considered, are being integrated, and each of those can have different interest in different levels. They can have interest in the product, they can be interested in the material, or in the three levels of analysis. So it depends also in the internal priorities. It depends on the kind of strategy that they are selecting in order to become more circular. But this is a matrix that will help you to analyze the level in which these decisions are being taken. Okay, so here I'm going to present, this is part of one of the traditional tools are very difficult to integrate the complexity of an ecosystem that it's including not only strategic decisions, but also the technological threshold in which they can move the production activities. For example, this is an example of how the biorefinery can have an impact if we change, for example, the decision, the business decision into producing more sugar instead of producing more biofuel. It also can be adapted according to the agricultural yield. If it was a good year with a good raining season, or if it was not, this has also an impact in the entire ecosystem, industrial ecosystem. And this can only be analyzed through a scenarios perspective, which is integrating not only monetary information, but also the business capability and the business decision that the business actors that are integrating this process can take into consideration. So the three main points is this kind of model, system dynamics model, are good means in order to have a good idea in the long term, because they can give interesting insights, for example, in 5 or maybe 10 years, which is not always the case when we are doing statistical analysis, because this could be very dependent on unexpected variables, unexpected activities. It also can or should integrate the role of the stakeholders. This is a very important part of the industrial ecosystem, of this industrial symbiosis, and the governance, how those actors of the industrial symbiosis are interacting, how they are coordinated, how the governance is taking part inside this kind of industrial symbiosis. Okay, so let's put this into perspective. So as I previously said, industrial symbiosis is starting to get attention from not only at global level, but also more specifically in Europe. We have a well-defined legal framework that it's allowing to have very relevant advances, really relevant progresses and roadmaps that will provide incentives into the development of this industrial symbiosis. But of course, those are going to be different according to the way in which those are implemented in the different countries, and the kind of incentives that the public actors will provide to this. So we can find different scales of action, national, regional, cities. So each one has their specific agendas. The best case scenario is that all of those are harmonized, that they are communicating in between them in order to have a multiplier effect. But this, as we know, this is not always the case. We need to encourage this communication, this fair data set into the different scales of policy action that will facilitate to achieve the circularity objectives. Here we have some of the European legal frameworks that have been included into the development of the current industrial symbiosis policies. We have Circular Economy Action Plan, the first version, the second version. Also, the European Green Deal has a lot into in the incentives of how to apply industrial symbiosis as a strategy. We also talk about the European Circular Economy Strategy Platform at the European level. And we have recently published one of the, in 2023, that I didn't include here because it's the latest one, a roadmap for circular economy in the high-tech industries and manufacturing. So this is also a policy document that it's including a lot into the industrial symbiosis incentives. But of course, if we make a comparative analysis, we can learn a lot into how different countries, for example, Czech Republic, Estonia, Holland, and France are applying or are trying to implement this circular economy guideline, industrial symbiosis, guidelines into their current context and their specific contextual situation. Okay, so again, I'm trying to not be repetitive, but I think that's the main part of this, one of the main outcomes of this lecture is the fact that out of our research, we find out the relevance that innovation has in the implementation of industrial symbiosis, but specifically the part of soft tech innovation. And we will see that in the coming slides, how the way in which the actors are collaborating, are getting connections, are having or defining their governance is going to have an impact on the implementation of industrial symbiosis. And this will help to move forward the agenda of circular economy in the European Union, which is the boundaries or the framework of our study. Okay, we have this example, which is in Lithuania. We analyzed all the policy documents that are being influenced, are being nurtured by the European policy legal framework. And this is translated into more concrete actions that are or have application into the territories or a national level. So we could identify that the industrial symbiosis strategy in Lithuania, for example, is taken into account or is built through the economic sectors. Is that good or not that good? Well, this is in discussion because one of the criticisms on that is that it will be better to define the industrial symbiosis implementation through the value chain or the supply chains activity that are sometimes crossing different sectors. For example, energy, electronics, all those are integrated into the automotive the automotive supply chain, let's say. So this is one of the criticisms, but in practical terms, in Lithuania, it's applying these 7 key sectors, economic sectors, into the analysis or the implementation of industrial symbiosis. The 5 more important that are getting attention for the Lithuanian government is the building sector, the energy, the electronics and the ICT, and the packaging and plastics, and the 5th is textile. Also, it's also mentioning organic materials and bio-waste, but not giving that much relevance, because in Lithuania is mostly focused on manufacturing industries, and they are putting a lot of attention into these economic sectors. Okay, so once we have identified the policy documents that are trying to implement this industrial symbiosis into the current arena, the national grounds, then we need to define how. But in order to do that, we need to have a decision tool that it's able to provide some allocation means and how to shape this transition, integrating the complexity. Okay. And we're getting into the outcome part. So this is how we define, how we made this research protocol in order to be able to analyze the complexity and the innovation into the industrial symbiosis. This is a European part. This is a European model, and it has 3 parts. First is the panel of experts. We identify, remember that I mentioned that we create this research protocol, integrating qualitative but also quantitative methods in order to be able to integrate as much insights as possible into the decision process. So once we define the variables that were identified in the literature review, the drivers that are pushing forward the transition and the progress of circularity in the implementation side, then we go through a panel of experts that we carefully identify, and those experts were part not only from academia, but also they were in the business sector, they were in the policy development. So it was a very, very wide selection of experts in order to have a well representation of what industrial symbiosis, or how this transition of circular economy could be implemented in Europe. Once we gather all the experts, then we identify, we made this matrix of causal relationships, and the idea here is try to identify the interrelation in between the previously identified drivers for the transition of circular economy. So we can see that for some drivers, it's a bilateral relation. For some drivers, it is very easily agreed among all the 14 experts, but for some others, it's very ambiguous, not always well defined. However, we succeed into producing this system dynamic model with the 8 resulting variables. And the idea here is trying to identify how, for example, an innovation increase through the macro scale databases that is comparable in the data set in the Eurostat databases, how innovation increase have or can have an impact, a positive impact in competition, for example. So once we identify or create this model coming or out of the matrix that the expert proposed to us, then we verify this relation with the empirical analysis used from 2010 to 2019, 10 years data set, where we identify that what was proposed by the experts had a very coherent behavior in the macro scale analysis that we implement. And finally, and I think that I'm in time, the idea behind this systemic analysis of the drivers is to identify how to get the more traction out of the policy recommendations that we could give. So how the multiplying effects could take place into interrelated ecosystem, how to, if we have the idea on, for example, if we can see here, we use the network analysis also regarding which was or what was the driver that has the most interrelations into this transition, circularity transition model. And as you can see in the middle is innovation. So innovation occupies a very central place because it has the most interrelations into the model, and it's the one that is having more track. And if we put investments and development into the innovation, then we can influence positively many other variables into the model. And this has been corroborated with the macro scale databases that we analyzed in the data sets. So finally, and just to open some discussion here, as we conclude that innovation is having a very relevant place in the system dynamic of this circularity transition, we could also identify how this innovation is very related with industrial symbiosis, and not only with that, but with the soft skills innovation, how the collaboration, the coordination among value chain members, how the digitalization of supply chain is filling a gap, it's having a multiplier effect, and it's has the potential to improve. We don't know how much at this step, at this level, but we know that it, according to the network analysis, it has the most connections into this model, that it has the potential to improve in a highest way the interrelations and the transition into a more circular ecosystem, industrial ecosystem. So that's all from my side, and I will be very glad to answer some questions if you have, or some comments.
I have a very operational question about industrial symbiosis. That is, I was wondering, how is it possible to assess the contribution of industrial symbiosis to material circularity? That is, to single out the contribution of industrial symbiosis to material circularity. I don't know if it is a quite trivial question, so feel free to to correct me if I'm wrong in the formulation.
Yeah, definitely. It's an important question. Because industrial symbiosis, as you mentioned, it has all this. It's not only about the coordination. It's not only about this soft skill. This coordination, this collaboration, it's their purpose is to entail this circularity of materials. So therefore, we need to have the assessment tools that will allow us to not only to measure the network connection in between the actors, but also to measure the circularity. So I'm thinking about some of the indexes of material circularity that could be also applied in this kind of ecosystems. The difficult part is that usually the data is not deaggregated. So when we're talking about the industrial symbiosis, it's a mesoscale, and it's hard to have confident information or real information about in this scale. We need really the engagement of the firms, the companies that are taking part of this kind of experiences in order to have a real assessment of the benefits that this is bringing into material circularity.
Okay, and just a very brief follow-up question, if I may. I was wondering if, since industrial symbiosis needs a network approach to provide some results, I was wondering if some network analysis might be useful to figure out which is recent work handover among all the participants in the network.
What do you mean with this natural approach, Curly?
Network approach.
Network. Yeah. Sorry, it's the connection.
Oh,
yeah, definitely.
Sorry, maybe
Definitely,
it's my bad connection.
Yeah. I fully agree with you. So, yeah, network analysis, social network is one of the tools that we need to consider. And that's why I think it's complex, embedded into the industrial symbiosis, because we cannot restrict only to biophysical questions here. The collaboration aspect is also very important, and also the individual leadership of some of the actors. It's has a very relevant role in the integration of the industrial symbiosis as a alternative strategy for circularity. So it's not possible, from my opinion, it's not possible to develop that top down. Needs to have a combination of good incentives, but also the bottom up collaboration or initiative from the industries.
Thank you.
Thank you.
Thank you, Pierluigi, for the question. Manuel, maybe I can ask you a rather basic question. All right, because this has been like boggling my mind.
Go ahead.
When you compare like in industrial symbiosis and circular economy, are they the same thing or like they are different in some aspects?
You missed the first part of the presentation. I mean, industrial symbiosis is considered, at least in the literature, in the current scientific literature, is considered as part of the circular economy. There are other kind of principles that are integrated in circularity. For example, long-lasting products, the effort to make them last more in the economy. Also, changes in circular business, for example, to put servitization or product as service. This is a different one. But we can also talk about recycling, which is a different figure, a different animal, because in recycling you're sending every material into the global secondary market. So you get rid of the integration of the partners of the network. You don't know who is using your waste, your residues. So this is alienating the relationship. But in industrial symbiosis, since it is a territorial development, all these questions emerge. All these questions are being raised up. So, yeah, of course, it's part of circularity, but it's not the only one.
So to micro question here then, when you said resilience is kind of considered by some people about to be part of like circular economy. This resilience, is it coming from like the resilience of manufacturing because of the industrial symbiosis, or it's like a different thing? And the second part is that like you said also that like when we talk about circular economy, we can have different perspectives, macro, meso, micro, right? Mm-hmm. How about industrial symbiosis? Is it also can be considered from different perspectives, or it's something micro?
No, definitely. I think that industrial symbiosis has some focus into the meso level. Mm-hmm. However, it has, or it needs to integrate also the micro and the meso perspectives, because the prices in the raw materials are going to define a lot of the exchanges in between the partners, and also the innovation that each of the partners in the industrial symbiosis is going to define the level of investment. And regarding the resilience, this is a very interesting part of the scientific literature. We know that the more diverse the question is, or the exercise is, the more resilient it became. But this is sometimes a tension that is created, because the more diverse, the more complex it became, and the more difficult it is to have efficiency or high levels of efficiency. So then, at the same time, we are reducing a bit into, or you are influencing into the resilience. And this is happening in industrial symbiosis also. So as any industrial ecosystem, they are subject to this dilemma in between more efficient processes, but at the same time more diverse, and they need to find a balance. But yeah, I when I was saying in the slide that it's not always integrated into the circularity processes, is mainly because resilience is more related into the industrial symbiosis part, and industrial symbiosis part is only one of the subsets of the circular economy literature.
Thank you. Do we have any more questions?
We have Mantas who raise.
Oh yeah, Mantas, please go ahead.
Yeah, thanks, Manuel, for presentation. I'm thinking, is there any rankings of the countries? For example, which countries are characterized by the more extensive circular economy? And if there are some rankings, how we do, according which indicators we do such ranking?
Yeah, that's another reflection. Actually, there are some rankings. There are some consultancy firms that are also making some lists about what are the countries that have been have moved forward more faster than others. But I can say that most of the indicators are a material. So they measure recyclability, circularity of material circularity, and some others are regarding legislation. So how those countries have implemented packaging initiatives or are reducing single-use plastics, for example. So those are like the two main pillars in order for these consultancy firms to make this ranking of countries. But it's very, I mean, it's very subjective, we can say. But still, it's a good exercise to see how the countries are being progressing in specific aspects.
Okay, thanks.
Thank you. Well, I think that's all.
That's it, right? Okay, I mean, regarding the previous answer you provided, Manuel, you said that industrial symbiosis can be good for resilience, right? Is circular economy always good for resilience?
Good question.
Just asking out of curiosity.
I can send you back another question. Is circular economy always good for sustainability? And this sends us back to a previous lecture that I heard from Pierluigi, which is not always the case. So we have some circularity rebound effects, and this is something that we need to. Same thing. It's for resilience. So we have some circularity rebound effects for resilience. So in some cases, when we overemphasize, let's say, in the efficiency, you are negatively influencing the diversity of the ecosystem, and then you are making the ecosystem more vulnerable. And this is something that one of the conclusions that I got from the analysis of the biorefinery that I did in 2019, because it was getting more circularity at the end, but it was influencing negatively the resilience, because the ecosystems by itself became more less resilient, let's say. Yeah.
All right. Yeah. Good. All right. I guess that's it, right?
Yeah. Thank you very much for having me, and thank you very much for all those interesting questions. And it was a very nice pleasure and a very nice discussion. Thank you very much, Manuel, and thank you very much for the nice presentation. And I appreciate everybody for being here. So if there isn't any more question, I guess we can conclude the webinar. Okay. Thank you, everybody. Thank you. Thank you. Bye. Bye-bye.